Good morning, AP Statistics. This is Mr. Kim. Today I'm going to talk to you guys about the review for Chapter 4, what the answer key, like what the answers to these questions are, but not only that, but to also explain how to approach these questions. Now, I know that I haven't actually went over a lot of questions with you guys for Chapter 4 specifically. There's, as you can see, for those of you who have already attempted to try this is no math involved whatsoever. It's mostly just trying to understand the importance of how to design a good survey, good experiment. And once you understand, like once you just get it, then that's really just the only way to really just study for it. Now, I'm gonna make a quick announcement. Most likely, I might have to postpone the test to Friday. I'll give you guys another review assignment for those of you guys who still feel uncomfortable taking the test. I do have another review sheet available for you guys, so I'm gonna assign you guys to that to do for today. Once this video is over, then after that, I'll go over the answer key with you guys tomorrow, and then we'll take the test on Friday. So let's start with the multiple choice for number 1 on Chapter 4. So a study of which candidate city residents plan to vote for an incoming election will be considered biased if. So which of the following will be considered biased here? So now we really just have to go through all the answer choices here. That's the only way around it. Individuals are selected randomly to participate from a list of city city registered voters. So that seems to be okay. So we're just going to put a little star next to it. Every 50th person on a registered voters list was contacted and asked to identify who they would vote in the upcoming election. So now for A and B, I'm just going to eliminate because we are trying to figure out which of the following would create a bias. This is a simple random sample method of doing things, and this is mostly systematic. So they won't really create a biased bias. Individuals selected to participate from the city's list of registered voters were first separated by gender, and a percentage of males and females based on the percentage of the voter pool were randomly selected. So this actually stratifies them into groups, male versus female. Okay, so you might get a difference between the two genders, but for a bias, it's still up in the air. The participants selected from a list of registered voters were contacted via telephone. Now that is definitely the one that's going to create a bias, because when we're doing it by a telephone, or when we're just doing it by we're selecting, it doesn't even say the word randomly in there, but by telephone it could create a convenience sampling bias where they might just hang up the phone, or non-response bias it could create. So we do not want to do it over the telephone. Rather, we want to go to individuals and ask them, in person as to how they feel about certain things. So you can create all these biases if you do it by telephone and create this convenience sampling methods. 2 clusters of registered voters from neighborhoods were chosen, and the entire cluster was surveyed, where one cluster was an urban section and the other is suburban. Again, this is stratified group between urban versus suburban, and see what the response would be. We can see the difference it may be in their opinions, but it doesn't really create much of a bias compared to D. So the correct one here would be D here. Which principle is not a necessary component? Well, there are 4 pillars, right? So randomization, replication, and control is definitely part of it. Imposing a treatment is honestly the definition of experiment. So it should be E for this one. Stratification is not really necessary for you to actually have in having a good, well-designed experiment. A study is considered biased when which of the following occurs? Okay, so it's considered biased if we have some sort of, let's say, well, actually, let's go through the answers here. So no placebo is used in the study. Systematic sampling is used instead of random sampling. Well, that is not really going to create a bias there. An outcome is systematically favored. Okay, so that generally creates a bias if we have actually that is the result that we already know. Then it might be heavily favored to become the outcome, and then it's going to create some bias in sort of ways. No control group is used. You cannot have a control group if we're simply talking about an observations here. No placebos used in the study. A and D are really due to experiments. A bias can be from surveys. So surveys don't have any placebos or control group. Rather, surveys is just surveys. So we're talking about bias here. So the researcher has an interest in the study. Remember, this is also part of the experiment. If the researcher has an interest in the study, the researcher might be more inclined to behave in certain directions, you might think. But that yes and no, that's an experiment. Also, at the same time, because they might be more motivated to conduct the study or whatever, you can't really just assume that it's going to create a bias. When you have an outcome that is systematically favored, so the answer to this is C for number 3. When you have an outcome that is systematically favored, it's going to have a one general opinion. Like if we're going to like say yes or no, if yes is heavily favored, then it's definitely biased in that direction. We want to take a survey where it's mostly 50-50. So that really creates a bias in person's opinions as to how they determine things. I don't know how else to explain it other than saying that C would be the best choice. Bias is from observations. Most of the choices here are from experiments. So there we go. A garden club wants to use a new fertilizer on their prized petunia patch in hopes of increasing the number of petunias produced per patch. A club member suggests they set up an experiment to see if this fertilizer is better than the fertilizer they used in the previous years. The patch can be divided into 4 sections, so 4 sections here. In order to run this experiment, 2 of the sections receive more sun. So there will be sunlight here, and there will be less sunlight here. So I'm going to just abbreviate with a smaller s, lowercase s. And what would the best way to be assigning the fertilizer? So we have this new fertilizer, I think. Yeah, new fertilizer. So new fertilizer here and the old fertilizers there. So we need to create 4 different patches where half of the new fertilizer patch will be receiving more sun, and the other half will not be receiving more sun. And the same thing should happen for the old fertilizers. Number the patches 1, 2, 3, 4. Randomly pick 2 numbers from a hat to receive the new fertilizer, and receiving 2 would get the old fertilizer. A is not true, because randomly assigning 1 through 4, that's a good way to start things off. But what if for new fertilizers, they both get assigned 1 and 2, and they all get the new, like a more sunlight, versus 3 and 4, that 3 and 4 are all the old fertilizers and they get less sun. Then we create a confounding variable. We want to assign each fertilizer to each treatment. So number 2 sections in the sun 1 and 2, randomly assign a new fertilizer to one section, the old fertilizer to the other section. Now this gives complete control over which one will receive more sun and which one will receive less sun. We have a new fertilizer getting one of the treatment, and then we have the old fertilizer getting the other getting the same treatment. Repeat this process for the shady section. So the answer is B, because the old and new fertilizers, they will both be imposed to these 2 treatments right there. Randomly assign one fertilizer to the sunny section and the other fertilizer to the shady sections. Okay, so like I said, the same problem with A. You don't know which one it's going to get assigned to. What if they both get assigned, so that like getting the more sunlight to the new fertilizers only? So we don't want to create those confounding variables there. Put the new fertilizer down in all 4 sections and grow a patch of petunias. Once they're harvested, repeat the process in all 4 sections, but now with the old fertilizers. This doesn't create any problem. It's just that it just takes too much time. Why would you do it twice when you can just do it once at a whole get-go? Choose either the shady or the sunny section to experiment with randomly assign 1 fertilizer to the first section and the 1 to the second section. Okay, so we are choosing just one of these, and then we are not considering the fact of the other one. But we want, if you read the context, we definitely want to study both shady and sunny sections. E only studies one of them, so it doesn't give you the complete package as to what you're trying to do. When would the use of placebo be recommended in an experiment? So this is quite tricky. If you're trying to think about a placebo is a physiological effect that comes from a psychological bias. I don't know how to call it, but when you take a fake pill, let's say that even though it has no biophysical effects, nor chemical effects, rather it's just all in your mind saying that, oh yeah, I am getting this new treatment, I am getting imposed to this new pill, this drug, so it might improve my overall physiological being. So if we want to talk about placebos, we have to put it in that context there. So when there are sufficient resources to warrant the use of placebo, yeah, I mean, okay, I'll just put a start to it. What type of warrants? I hope they could be more specific with that. If the existing treatment is one that the researcher doesn't want to be included in the study, that really doesn't have anything to do with the placebo. Placebo has everything to do with just mind and how that affects the body there. If the placebo can be used with animals, okay, I I honestly don't know how, like with animals, it's animals to human beings with placebos are usually imposed on human beings. It doesn't really have any impact on the animals. I mean it doesn't they don't usually create experiments with the animals to use placebos. When there isn't an existing treatment and you want to be sure that the subjects feel they are being treated, okay, that's definitely D. So there isn't an existing treatment. You want to be sure that the subjects feel that they're being treated. So like I said, it's all in their mind. Oh yeah, I am getting this new drug, so I feel like I'm getting better. That type of thing you want to eliminate. That's when you want to use the placebos. You compare placebos to the actual drug effects. Um, Anyways, yes, so that D is just the answer here. To make sure the placebo works before using it on the other studies, that's really the aftermath of it. The reason why you want to use placebos is because you want to make sure to eliminate that confounding variable of the subject's psychological state, because that could also explain as to why they are getting better when they're imposed to this fake pill. Variables are considered to be confounded if, so variables are considered to be confounded means it's an alternative explanations to the response variable. All right, so let's go over these. They are both studied as part of the experiment. Their effects on the response variable cannot be separated. The more than one additional treatment group is included in the experiment, the response variable is controlled by a placebo. Okay, I'm going to eliminate a couple of answers here that makes no sense. The reason why I'm eliminating B and D is because B, their effects on the response variable cannot be. Oh, I'm sorry, not B. A, they're both studied as part of the experiment. I feel like A is just too general. Like if it's confounded, then it needs to be specifically saying something regarding to how it explains the other part or provide some alternative source as to how the response variable can come to being. Randomization wasn't used in setting up the initial experimental study. Okay, well, if you don't have a randomization, that definitely can create some sort of a confounding variables there. But let's talk about this here. So let me just go over this here in a much more detail. Of C and E or B, their effect on the response variable cannot be separated. Okay, so there's word response variable, so that actually gives it away. More than one additional treatment group is included in the experiment. So what we want to say for this one is one additional treatment group is okay. So that doesn't really create the confounding variable. Confounding variable means that it provides an alternative source to the response variable, like I told you before. If that's the case, then the only way that I can explain it is B, because that's the only one that contains the response variable. So their effects to the response variable cannot be separated. It's some sort of it's another way of explaining the response variable. In other words, it is a vital source to the response variable that you cannot get rid of. So it has some impact on the results. Randomization, that definitely can create the confounding variable, but if we're talking about a confounding variable as a main thing, we want to say that B is the better choice than E, definitely. The key difference between an observational study and an experiment, this one should be quite simple, guys. It should be the treatment. Yep, the application of a treatment. The word treatment has to be in there if we're talking about the difference between observational study and experiment. Observational study is just you making observations, versus experimental study is when you're actually imposing treatment to the subjects. Number 8, which of the following doesn't reflect some form of bias? So choosing AP students to survey regarding their GPA determining. Okay, you can see obviously why that would create a bias. AP students, they're more highly motivated, more calibrated to have a higher GPA compared to the rest of the group. Polling a group of potential voters outside a Republican group. Okay. Well, potential voters include Republicans, so you want to include that as well. Surveying a group of factory workers regarding the fairness of management policies throughout a company. Okay, so factory workers out of throughout the company, I mean, they might have something to say about how the company runs things. So if we're just representing factory workers, that's not a representation of the whole group, and they might be biased in certain directions. Choosing a stratified random sample of juniors and seniors to see which university they intend to pursue. Okay, I like that. I mean, juniors and seniors to see which university they intend to pursue. It's not like I'm asking them to be biased towards juniors and seniors. Rather, these are the students who are more inclined to think about their college prospects and future and beyond. So there is no bias that I can see from D. Asking shoppers leaving a grocery store if they think groceries should cost less. Yes, that's definitely bias. Before and after, if people are coming into the grocery store, they might be thinking not that much about how much groceries should cost, but after they pay for what it really costed, then they might have some sort of a biased opinions about how they feel about the grocery prices. So it's definitely D for this one. That doesn't create any sort of bias. A church board wants to survey the members to see which times they prefer to have services. The board wants to ensure that members who have families attending as well as members who are single adults are represented in the survey. So families and single people, which method will yield the best representation of the sample? All right, so I can already see that D and E is not really going to help, nor C, because have a designated person survey every case person. Okay, so but then that might not give you a fair number of group of people for single and families. We don't want that. So it's really between A and B, and you guys can probably kind of street smart your way out of this. It's usually the longer answer. So it is definitely B for this one. But quite honestly, the reason for this is because it actually contains the two groups. If you read A, send a survey to a random list of 50 members and ask them to return it in a self-addressed envelope that was sent with the survey. All right, so it's random list of 50 members. Okay, are they single or are they families? It doesn't really tell you. Separate church membership into two lists, families and singles. Randomly choose 25, so half and half. And then we get their opinion so that we get the fair group of fair number of people that are both in those categories, regardless of the total and like the population size there might be. We can get the opinions from these two groups in a much more a fair manner, if you will. So it's definitely B for number 9. Number 10, which of the following are true statements? Convenience samples are rarely beneficial. That is definitely true. It's rarely because convenience can be beneficial in the sense that if you're running low on time, you can get at least some sort of survey or studies done within a short period of time. So it can be beneficial in a certain degree, but it creates so much bias that it might not be useful for making any sort of comparisons or conclusions based on it. 2, blocking should be used if race, gender, or some other factor may affect our results. Yes, that's definitely true. Blocking is a fancy way of saying groups. So if we group them into race, gender, or some other factors, and then make an experiment based on those results, then we can actually eliminate some sort of a little bit of a confounding variables there. Part 3, all experiments should be double blind if possible. That is also very true because the more blind it is based on subjects and the people imposing the treatment, the more unbiased results we would get. So blind means that both the subjects nor the experiments, the people who are conducting experiments do not know what type of treatment they're imposing or what type of treatment they're receiving. So it eliminates that kind of psychological effect side out of it. So as much as possible, if we can create a blind experiment, we should go for it because it eliminates bias. So that's the type of relationship that I want you guys to remember. All right, so number 11, why is a double-blind procedure used in an experiment? So the double-blind procedures, like I explained before, the main purpose of it is for you to eliminate bias on the subjects as well as the people who are imposing the treatment. If they do not know what they're imposing or what they're receiving, it's going to eliminate the psychological effect. So to avoid interfering with results by contaminating subject with information, I like A already, okay? It interferes with the results by contaminating subjects with information. We are not telling them what they're doing, like what treatment they're imposing, what treatment they're receiving. So it's going to create this pure, innocent opinion / results without having any outside effects of the subjects or the people who are imposing the treatment. B, to ensure the treatments are randomly. Okay, that's not true. It doesn't have anything to do with randomness. To keep all subjects unaware of which treatment they're receiving. Well, not just, okay, so the main reason for that is for you to get pure results, not so that you can make subjects unaware of things. C is definitely part of blind experiments, but it's not the reason why we're doing such things. To avoid talking to subjects, nope. To easily replicate, nope. It's definitely A, and if I verify the answer, yep, it's definitely A for this one. A car manufacturer is concerned about the time it is taking for batteries to be installed in an assembly line. The use of a new tool has been suggested to reduce the time spent on this part of the assembly process. Which of the following would be the best way to establish if this new tool works better than the old tool? All right, so we have an assembly line, we have old tool versus new tool, and we need to design an experiment. So let's go through each of these answer choices. Randomly assign pairs of 2 workers to perform the task. One would be assigned to use the old tool and the other worker to use the new tool. It depends on how good these workers are. So if we got to make sure, if this is what we call a matched pairs design, we have to have 2 similar people, 2 similar workers, and the same skill level to be imposed to one with the old, the one with the new, and then compare the results, and we can make some fair comparisons. Because if one is actually better than the other in terms of their skill level, then if you impose the let's say the more experienced, more veteran in terms of designing, on the assembly line with the old tool, and with the new upcoming rookie with the new tool, and then their skills has been elevated to the point where like it's not their fair skill, then it's going to give some sort of a results that's not something to your it's not to your likings. We want to make some fair comparisons at their same level, and then how does the tool, not the confounding variable of the skill set levels of the workers, but just strictly the tools. And so A doesn't really address that issue at all, so we have to eliminate that. It can be depending on the skill set levels of the workers. B, randomly assign a few workers from various shifts, day and night, to perform one of the assemble process. This could also impact the performance of the workers. If you're having a night shift, they could be a lot more tired. They could be, psychological, physiological effects of just day and night can impact how the workers are going to do. It doesn't necessarily have to do with old and the new tool that they're using. Remember, we're trying to eliminate as much of the confounding variable as possible. A and B actually creates one for yourself. So randomly assign workers to perform both assemble tasks. Each worker will be randomly assigned to begin with one of the 2 methods, and then after a set of time, change to the other method. Results will be measured by pairing the old versus new. I like C already. So C is definitely an example of a matched pairs design, where one worker would be, let's say for about set time, they would be using the old tool, then for the same set of time, new tool, and compare the time results or any other results that they want to find. Then you're really comparing just the tools, new versus old. The same workers using with the same set of skills of hands, they use the old tool for a set amount of time, they use a new tool for a set amount of time, and then you compare the results. That is definitely one way to go about this. Randomly assign 4 workers to one task to be performed for a month, and to change to the other assembly task for a month. This one should be okay, but 4 workers to one task to be performed for a month, and then change to the other assembly task for a month. This one's okay, but comparing with C is definitely a much better choice here. Assign 2 different assemble lines of workers to use one tool, and then compare the 2 lines. Okay, but we're talking about 2 different set of lines of workers. One uses new tool, one uses the old tool. It kind of gives you another confounding variable to skill set levels of how these people are doing in each assembly line. Therefore, E is not the correct choice. 12 is, yep, definitely C. All right, a psychological study is to be performed that has 5,000 menopausal women participate in a biofeedback regimen to see if this will help calm the emotional bounces typical for women at this stage in life. In actuality, 2,500 of the women receive biofeedback, and while the other 2,500 will be in the control group and given no additional treatments. Women agreeing to participate will be first classified. Okay, so this is the key here. So first you have this 5,000 menopausal woman, and then you have this first be classified word. That gives you an idea as to, okay, so they're trying to level the woman's menopausal level or their psychological state as to either the emotional distress they experienced was mild, moderate, or excessive. From that, what can they do? They can level off as to where person A, let's say it's described as mild, and then person B, who's also described as mild, can be matched into something called matched pairs design again. So this is, again, matched pairs design experiment. The reason for this is because we want to give person A and B, this one and the other group, where one group will be imposed to the biofeedback regimen, so impose the treatment, where B would be the control group. But that same level of, let's say, emotional distress they experience, those two people, you will pair them off to compare the results. So this is not an observational study, obviously, because we're imposing treatments. Simple randomized comparison experiment would mean that I would just have to assign numbers 1 to n and then just use random number generator. Those words are definitely associated with simple random design. Now, a single blind and a double blind where the subjects do not know, or where the both subjects and the people who are imposing the treatment, they don't know. For this, because it doesn't contain the word matched pairs design, I mean, we are leveling off the subject's level of emotional distress for that particular reason. We want to match the group up. Therefore, the only answer for this is E. Double blind and a single blind, quite honestly, reading from this perspective, we do not know if they don't really say, oh yeah, these subjects do not know. They're not actually aware of whether they're receiving a treatment or not. It doesn't say that the experiments, people who are doing the experiment are aware of what type of treatment they are imposing to the subjects. They don't really specify that here at all. So how are we supposed to tell? The only way that I can tell you from this answer choice is because it contains the word match pairs. I mean, that really just gives it away. This is a perfect example of a match pairs design. All right, number 14, the mathematics department wants to see if the use of a software program will improve scores in their geometry course. The department has decided to set up a small experiment with 10 sections of geometry. They have 2 teachers who have volunteered to participate and use their sections of geometry. Ms. Smith is going to use the software alongside existing classroom materials, while Mr. Jones is going to use the current classroom tools only. Each teacher will use 5 sections of geometry taught in blocks 1 through 5. The student will be given a pre-test as well as the post-test at the end of the course. So what treatment is being studied? All right, so first of all, the treatment that we are imposing, this is actually it's not that bad. It's the software program's effectiveness, right? I mean, I don't really think I have to go over in too much detail about it. We are getting the groups. I mean, it goes in length just to describe how they are going to make the sample out of these 2 teachers group of sections of geometry, but honestly, we're just measuring the software's effectiveness on the kids. 15, a large university English department wants to survey students regarding satisfaction with their English courses. 20% of the students are graduates, while the 80% are undergraduates. How would you make this study? Okay, so we're using a cell phone text poll. That's new. All right, so randomly select 10 English classes from a list and have all students in these 10 classes. All right, so that's okay, but it doesn't really specify the graduates or the undergraduates, so no. Randomly select 2 graduate English classes, as well as 2 each from freshman, sophomore, junior, and senior. So that's a total of 8 if you do 2 times 4. So 20%, 80%. Numbers are all matching up. The stars are aligning to say that it's going to be B for this one. So we get 1 course of graduate course, their opinion about the English course, and then freshman, sophomore, junior, senior, that's 4 courses, and then we have 2 students from each, which will make the sample size be perfect representation of the population size as well, because they said 20% of the population are graduates and 80%, while the 80%, the rest of them are undergraduates. So B matches the population demographics perfectly. C, using a computer-generated list of English classes, randomly select participants to take the poll during the designated time that week. Again, this computer-generated list of students, you usually say, oh yeah, we have to do that. But for simple random sample, yes, that's great. But again, it doesn't really give you the groups, graduates versus undergraduates. From an alphabetical listing of students in the English classes, choose every K student. Again, it doesn't really give you a good, like it's okay, but it's not as great as B. All of these other answers, randomly select 5 graduates and 5 graduate classes. We don't want to do that because that is actually not perfect. This is 1-to-1 ratio. It should be 1-to-4 ratio from graduates to undergraduates. C and D are semi-okay, but it doesn't give you a perfect representation from 1-to-4 ratio because it's randomized, right? Who knows how many undergraduates or graduate students that you're going to be able to pick. So B is definitely the correct choice here. 16, which of the following can be used to show a cause and effect? Guys, when you see cause and effect, please understand that only comes from experiments and experiments alone. Surveys / observational studies, they do not provide you with any sort of cause and effect relationship. A census is in a way a population survey. Like you go out and ask everybody. It's a generally understood that this group of people, well, the entire population of this group will say this. Census is an example of an observational study, so we can't say cause and effect sort of thing. Controlled experiment, observational studies, sample. Okay, all of these are survey / observational studies. Therefore, we are eliminating all those processes, all those choices, and then the only answer that we're going to get is B. Okay, only experiments can show cause and effect. To check the effect of cold temperature of the elasticity of the 2 brands of rubber bands, we have brand A and brand B. Brand A is placed in the freezer. Brand B is kept at a room temperature. Okay, there's a red flag there. Okay, so saying that only one brand is imposed to one type of treatment, while the other brand is just imposed the other treatment, that means you're creating a confounding variable for yourself, saying that you're not testing the temperature on the two rubber bands. Rather, we need to use the same brand of rubber band to two different types of treatments. This could be due to the fact that this brand A could be better than brand B, or brand B could be better than brand A. The brands can be actually the confounding variable here. So we want to eliminate that. So it's definitely not a yes. No, because temperature is confounded with the brand. That is the word we want to use. More temperatures. No, we don't want to use more temperatures, because more than 2 brands. No, it doesn't really necessarily have to be more 2 brands. It's definitely not a good experiment because we have a confounding variable of brand. 18, physician's health study. A large medical experiment involving 22,000 male physicians attempted to determine whether aspirin could help prevent heart attacks. In this study, one group of about 11,000 physicians took an aspirin every other day. All right, so we have a half of the group taking aspirin, while the other group is a control with the placebo, fake pill. All right, so why would it not be appropriate? The study included only physicians, and different results may occur in individuals in other occupations. That's definitely true. People who are required to work more, who are required to work less, people who have a very higher stress environment, less stress environment, that could all be an impact as to how a heart attack occurs. A study included only males, and there may be different results for females. Gender, definitely another confounding variable there. Although taking aspirin may be helpful in preventing heart attacks, it may be harmful to some other aspects of health. So 3 is more of an ethical issue. We are just making 11,000 physicians took an aspirin every other day. I mean, that's quite unhealthy. So it's not a good, appropriate thing to do or to say. Taking aspirin every other day will improve health or improve heart attacks, because if some people, based on that cause and effect relationship, tries to take aspirin every other day, but form some sort of other type of disease, that is on the surveyors or the people who's doing the experiments. So we don't want to. 3 is also part of it. And quite honestly, if we're just looking for 1 and 2, it's not even part of the answer choices. So it's definitely E for this one. 3 is more of an ethical issue, like I said, so it's not an appropriate thing to do. Number 19, last multiple choice. The student government at high school wants to conduct a survey of student opinion. They want to begin with a simple random sample of 60. Okay. All right. So simple random sample of 60. A, we can see that it's going to be very convenient. So it's going to create bias. So we don't want to do that. Survey every 10th. That's systematic. Use random numbers to choose 15 of each first. Okay. I like that. Remember, random number, random generator. That's all have to do with simple random sampling. Number the cafeteria seats. So we're just doing people from the cafeteria for part D. It's not a representation of every survey of student opinion, not people from just one period of cafeteria alone. Although it might be a good representation, but we don't have enough information about this cafeteria. It could be freshman lunch, sophomore lunch, depending on which school you go to as well. Number of the students in the official school roster. Use a table of random numbers to choose 60 students from this roster for the survey. Oh, I'm sorry. We're talking about simple random sample, and I completely forgot that C was stratified. Sorry about that. So stratified random sampling is in groups for first year, second year, third year, and fourth year. E is definitely the correct choice because E is simple random sample of just entire population in general, and we're picking 60 from it. Whereas C, we're picking 15 from each group, so that should be stratified. So we do not want to pick C. Sorry about that. That was my fault. So it should be E for this one. Okay. All right. So free response. Number 20, a manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing to the current method. The appearance of the boots is not changed by either method. The company recruits 100 volunteers in Seattle, where it rains frequently, to wear the boot as they normally would for 6 months. At the end of the 6 months, the boots will be returned to the company to be evaluated for water damage. Describe or design this experiment that uses 100 volunteers. Include a few sentences as to how it would be implemented. Okay, so first of all, we want to see if this new method of waterproofing will actually do less damage, right? What that means is we have to have comparison. One boot that is imposed to this new treatment and the other one not imposed to this new treatment. Now, there could be like several ways in which you can do this. If you take a look at the answer key, it also kind of tells you as to how they will design it. So this is a match pairs design. Why is it match pairs design? Because you yourself can be alone as a subject, can be in two type of groups of where you're trying to do the experiment. So match pairs design simply means that I am trying to study two group of things, two different type of, I would say groups from one person only. And we have 100 volunteers for that. So we have 100 results coming from each of those subjects. So how would I be able to design it? So first, we can say have people in the Seattle, have the subjects wear the boot that was imposed to the treatment, which being the new method of waterproofing. For set amount of time. Then have the same people wear the boots that was not imposed to treatment. This will be your control group for the same set amount of time. Then you will compare the results. Compare the results from each subject, the type of damage on their boots imposed to treatment versus control. I know my handwriting is not the best, but here's what they're talking about. For one single person, let's say this person is wearing a boot like for about, I don't know, a month with this new imposed treatment of this waterproofing method. So they wear this for a month and see what type of damage it did. Then you wear this same brand, same shoe. It's got to be the same shoe on the same person. The only difference is that it does not contain the new waterproofing method. And then for about a month, the same amount of time. Every other variable is kept the same. The only difference is that it was not imposed to that waterproofing treatment. Then you compare the results. Does the first set of boots from that same person, like person number, I don't know, 1, 2, 3, 4, have like what type of damage it did to the boots versus what type of damage did it do to the other set of boots? And then you can make the comparisons there. So this would be an example of a matched pairs design. Obviously, this would be a way that I would write them down. But it's gotta be some variations to this. Okay. Don't give me like a 1 or 2 sentences for the test, by the way. You gotta make sure you have a really good, like a chunk of short answer type of thing. Okay. Like, more than 1 or 2 sentences, basically. Could your design be double blind? Explain. Yes, particularly because not only does it, like, double blind simply means that the subject and the people that is imposing the treatment, or people who is conducting the experiment, they just simply don't know what type of treatment they're receiving. So both subjects and the people who are conducting the experiment cannot be aware of what treatment the subject is receiving. So what that means is, like, one day, on the particular day when they're first about to receive first set of boots, both the subjects nor the people who's actually giving the boots, and like they won't know which this would be. Like, is this the boot that contains the new treatment or not? They could not be aware of it, or they might not have been informed. So experiment cannot who are conducting the experiment initially can be not aware of what treatment the subject is receiving. I think that should do the trick. I think for the answer key, the design could be double blind as long as the subject and the person evaluating the boots for water damage do not know. Okay, so pretty much saying the same thing. Putting in your own words, make sure that you specifically say double blind. Double means both, two things. Both the subjects and the people who are imposing the treatment, they don't know what's going on. They don't know what type of treatment they're receiving. 21. There have been many studies recently concerning coffee drinking and the cholesterol level. All right, so we have 300 non-smokers who each drink 4 cups of caffeinated coffee per day. Each of these 300 participants will be assigned to 1 or 2 groups. The experimental group will drink coffee, will be made with a new filter, with a control group who will only drink coffee that has been made with the standard filter. So we're comparing standard filter to the new filter. Describe an appropriate method for assigning the subject to 2 groups so that each group will have an equal number of subjects. As you probably have guessed, most of these random grouping sampling methods usually entail the first sentence to be 1, assign each participants numbers from 1 to 300. Use random number generator to pick 150 of the 300 numbers. And this first group will drink coffee, or you can just copy and paste. We will drink 4 cups of caffeinated coffee on a day we'll drink coffee using the new filter, while the rest will be given the standard filter. Okay, and then so they will drink coffee and then compare the results from that. So assigning the subject to the 2 groups so that each group will have an equal number of subjects. So we're just solely focused on getting 150 on each group, 1 group using new filter, the other group using the standard filter. In this study, the researchers chose to include a group who only drank coffee that was made with the standard filter. Why is it important to include the control group? Well, that's solely because we want to make sure that the cholesterol level is not impacted by anything else other than the coffee filters alone. So the real reason as to why we want to include the control group is to eliminate the confounding variable that can result in influencing the results that can result in influencing the effect of coffee filters to the cholesterol level. So let's say that we have 150 people that's using the new filter alone. We measure the cholesterol levels from before and after. What if it has to deal with something else other than the coffee filters themselves? Maybe it could be due to their age, due to their job, due to what type of environment they're in. So it may not just solely be due to the fact that it could be from the coffee filters alone. So the reason why we want to include the control group that uses a standard filter, so that we can really compare people that are using standard filters, regardless of their gender, race, age, job, what type of job they have. This group is using standard, and versus this group is using new filters. So we can have those different variability in terms of, all of these other confounding variables in this group or the other. But if we have the control group where this one using standard versus new filter, then we can really see the difference in the cholesterol level of before and after from one group that has everything the same, but only difference is that they use standard versus the new filter. So it's really just to eliminate all the confounding variables that can result in there, and then we can make sole comparison to, so that we can make sole comparison to standard. Keep calling it old for some reason. Standard filter to new filter that impacts the level of cholesterol level. Impacts the level of cholesterol. Yeah. All right. So this one, let's see if I go down here. Without a comparison group, the cholesterol level could change overall, but it will not be able to determine whether the observed changes was due to some other extraneous variable. Like I said, it could be all of these other confounding variables that could influence the result. Therefore, if we want to eliminate that, we got to have the control group there. Why would the researcher choose to only use non-smokers? I mean, that's pretty obvious. Smoking is definitely one of those confounding variable. So if you have a smoker versus non-smokers in that group, let's say 75 of the people who's in that 150 group, half of them smokes, half of them doesn't smoke, then smoking definitely impacts the overall health as to how a person's doing. But that is not what we want to study. We want to study the coffee filters. Is the coffee filter the sole reason as to why the cholesterol level is going down? If I want to check for that, we definitely have to eliminate the smoking as one of the confounding variables there. So if you read the answer choice, if it is known that the smoking is related to changes in the cholesterol level, it would be best to control for smoking by using non-smokers. So Jeff, definitely say that we want to eliminate the confounding variable of smoking, that because smoking impacts the cholesterol level. Therefore, that we want to use only non-smokers in the study, just to solely study the effects of the coffee filters to the cholesterol level. Okay. All right. 2 more questions to go. Number 22, Gallup Poll asks, do you think U.S. should take the leading role in world affairs? We have, a major role, not the leading role, minor role, or take no role, take the leading role. So we have these options to pick from the survey. Gallup's report said results are based on a telephone interviews with 1,002 results, age 18 and older. What is the population? Adults aged 18 or older, obviously, because that's the entire population of where you want to get the results from. Sample size, and it was equal to 1,002. They tell you that right out of the way. Gallup noted that the order of the 4 possible responses was rotated when the question was read over the phone. Why was this done? So let's say you get the survey and you are read out loud what the choices were: leading role, major role, minor role, or no role. If you are actually, let's say, hearing this choice first, the answer to this basically is saying that you want to rotate the answers so that you don't get this response bias where it comes from the subjects themselves, where the first thing they may hear might be their answer because they want to get over with the survey as quickly as possible, or whether whether they are thinking about in one way, shape, or form of how the U.S. should take place in the world affairs, depending on how the order of the answers were read, it can influence their decision. So if I read the answers to this, it's really just meant to reduce the bias as much as possible. The answers to the questions, like the orders of how they are structured, can impact how they answer the survey. So definitely we want to rotate the answers so that we can eliminate that bias as much as possible. 23, the last question. University's financial aid office wants to know how much it can expect students to earn from summer employment. This information will be used to set the level of financial aid. The population contains 3,478 students who have completed at least 1 year of study, but have not yet graduated. A questionnaire will be sent to an SRS of 100 of these students drawn from an alphabetized list. Okay. So describe how you would select a sample of an SRS. You should know the deal. Assign numbers from 1 to 100. Use a random number generator to pick. I'm sorry, not 1 to 100. We're picking 1 to 3,478. Use a random number generator to select 100 of these 3,478 numbers. That will give you a group of 100 simple random sample group or sample group. Part B, use the portion of the random digits below to select the first 5 students in the sample. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. A long time ago, I've showed you guys how to use a random sample, but I'm going to show you guys how to do this once again. So obviously for the TI-84s, you cannot put all these numbers into a list and get the random number, use a random number generator to select the numbers directly from this for you. For some reason, the shared screen has frozen, so I'm actually going to stop sharing the screen and share it again for you guys. All right, so there we go. So this didn't show up. So 1 to 3,478. Use random number generator and then select 100 of these numbers. So that's how you would select the sample. Let me show you guys on this thing. All right. So what I'm going to do is I'm going to assign numbers from 1 to 16 from here to there. So if you go to math and go to the probability section, and if you go to the random integer, random integer, a lower number will be 1. 16 is the last number. We're not literally typing these up. Rather, we're just giving them the list of numbers like this: 5, 6, 7, 8. So we're just telling the number from each position. And I'm picking 5 of these numbers. And it gives me 16, 15, 3, 9, 7. So 16 will be 47487. 15 will be 50,211. 3 will be 69,971. The 9th number will be 68417, and the 7th number will be 17297. So again, using random number generator to pick numbers is not a big deal. Just use the TI-84 and you should be able to get the job done from that. Okay. I know that this chapter hasn't been really elaborate. We haven't done any sort of math. It's just a matter of, designing an experiment, looking for the biases. If there are any potential bias, how can you eliminate them? That is the main bulk of this chapter. So please make sure that you study over that. I will give you one more set of reviews by the end of today. So please study over that. I'll make an announcement that it's not going to be, it is not going to be on tomorrow, but rather it's going to be on Friday for the test. All right. Thank you guys so much and have a great day.